Okay. So assignment 4 is here. Okay, so do you see the questions? So for question 1 is quite straightforward because they want you to find the amplitude and period. Okay, so for example, what is the amplitude for part A? Tell me. It's easy. I mean, it's just written there.
10.
It's 10. How about the period for this guy?
-6.
No. Remember, if you have like, whenever you have, let me just write it. Whenever you have f of x equal to sine or cosine, I just write cosine, but sine is also the same, exactly the same. So if you have a function like cosine of omega x or kx, I sometimes write, then omega so omega is equal to 2 pi over t. In other words, t is equal to 2 pi over omega. Okay, so the period is 2 pi divided by omega. So for example, if you have like f of x equal to cosine of 6 times x, t period is equal to 2 pi over 6, which is equal to pi over 3. Okay. Or if you have something like f of x, like part B, sine of pi x, then again, the period t would be equal to 2 pi over pi, which is equal to 2. And the reason is that, let's look at this, the former function closely. So the reason is that, so if you just put f of x plus 2 is equal to sine of pi times x plus 2, and it's equal to sine of pi x plus 2 pi. But because sine is periodic with period 2 pi, so this is just equal to sine of pi x. And this verifies that 2 is actually the period, right? Because sine of pi x is just f of x. So f of x plus 2 is f of x. So Yeah, the period is the smallest number. So this is called sometimes the principal period. Is the smallest number t for which f of x plus t is equal to f of x. Okay. Any question about problem 1 of the assignment?
No.
So Andy, can you tell me what is the period for part C? Oh, here you go. I just asked you a question. That's fine. Never mind. That's fine. Just have a seat, relax. Alan, you tell me, what is the period of part C?
Part C. 2 pi over pi.
Is 2 pi over 4, right?
Yeah.
Which is equal to?
Which is equal to pi over 4. No, 2 over 4.
No.
Wait, hold on. What?
Two pi over 4. It's 8.
Yes, 8.
Right? Okay, so the period for part C is 8. Okay, guys. So question 2 is just drawing a graph. Again, it's straightforward. I mean, you can start from cosine of x and then you do the transformation. First draw cosine x and then draw cosine of pi over 4 times x. And then minus cosine of pi over 4 times x. So we can do like this. First, y is equal to cosine of x. Then y is equal to cosine of pi over 4 times x. Then 3, y is equal to minus cosine of pi over 4 times x. And then at the end, y equal to minus cosine of pi over 4 times x plus 1. So the last step is a vertical transformation upward with 1 unit, right?
One
And
unit
let me,
upward,
pardon me?
upward or downward.
Upward, because it's plus 1.
It's minus 1. 1
No,
minus.
no, this is plus 1. This, look at this.
Oh.
It's 1. And then, so once you have minus cosine of pi over 4x, then you add 1. So you take you just push it up 1 unit. Okay. So for if you, and let me help you draw cosine of, so you know cosine of x.
Yeah.
I assume you know cosine of x, okay? So cosine of x, so let me just write the minimum and maximum. Okay, imagine this is cosine of x, okay? Oh. And so on. So the points on the graph that are important is just, this is 0, so it's obvious. So y, x. But this point that crosses, what is the first x-intercept? The first x-intercept. Pi over 2, right? The minimum here, -1, is pi. And here is 3 pi over 2. And then the next maximum would be 2 pi. Okay, and so on. But this is y equal to cosine of x. What if you have cosine of pi over 4x? So I just copy this. You just have to modify this a little bit. It's not a big change. So here I want cosine of pi over 4 times x. It's a stretch, vertical stretch. So the only thing that changes is these points. So what is the first x-intercept? Tell me, at what point cosine of pi over 4 times x is 0? Or let me just draw it in an, yeah, at what point cosine of let me erase everything. At what point it's 0? Cosine of 4 pi times 1 over 4 pi times x. X equal to 2, right? So instead of pi half, the first x-intercept would be x equal to 2. So is a 2 is something between pi half and pi. So it's something like this. This is x equal to 2. And then what is the first minimum? So the maximum is 0. It's the same. X equal to 0. The first max, I mean, the first positive. Or what is the first minimum after x equal to 2? The point 4, right? X equal to 4. And then what is the next x-intercept? It would be What? X equal to 6. And the next maximum would be
8.
8. So it goes like this. Oh, sorry, let me. You see the stretch, it's a horizontal stretch. It's like you stretch the graph, right? This is like 8. Okay? And then when you minus, you just flip this graph. You just flip it. When you multiply by negative sign, you just flip the graph like this. You see the red line. So the red line is y is equal to minus cosine of pi 4 times x. And then finally, the last step is a vertical transform upward, 1 unit. And I leave it to you, okay? I mean, that's easy. Any question about problem 2? For question 3, I assume you can do it. Let me know if something is not clear. And for question 4, you can either draw the graph or you can use the fact. So for instance, let me just pick something random. So if you have a function like f of x equal to 4 times sine of 3x plus 10, I don't know, something like this. So you can find the range by algebraic manipulations or algebraic justification. That means, so first of all, we know that sine of 3x, no matter what, I mean, it could be 3x, x, 2x, it doesn't matter. So it's always, regardless, it's always between -1 and 1, right? That's the range of sine. I mean, sine of 3x is also between -1. So that means 4 times sine of 3x lies between -4 and 4. And if you add 10, 4 sine of 3x plus 10 is less than 14, greater than what? If you add 10 to this inequality,
6.
it's within 6. So that's the minimum point is 6, maximum point is 14. And that makes sense because the minimum point is the point where sine is -1. So when sine is -1, so 4 times -1 is -4 plus 10 is 6. That's the minimum point. Maximum point is the point where sign is +1. So you get 4 times 1, which is 4, plus 10 is 14. So you just need to find the maximum point and the minimum point. Here are 6 and 14. But just be careful, these are for sine and cosine. For tangent, the range of tangent is everything, is the whole real numbers. So f of x, if you have tangent of x, this range, a range of f, is the set of whole real number. Okay, let me know if you have any questions. And what about, okay, so another thing is arctan. So you know arctan, the range of arctan, let me draw the function arctan, is the inverse of tangent. And you should know the graph of arctan. So arctan lies between pi half and negative pi half. This is y, x, this is pi half, negative pi half. So arctan goes like this. So you have a horizontal y equal to arctan of x. So you have horizontal asymptote. So you have two horizontal asymptotes. Horizontal asymptote. One is y equal to pi half, and another one is y equal to negative pi half. So the range of arctan, so range, so if f of x is arctan of x, so the range is the open interval minus pi half and pi half. So arctan is always between minus pi half and pi half. Okay, so arctan of x. Now, if you have something like f of x is equal to 2 times arctan minus, I don't know, pi, then what you can say? So you can say that, first of all, we know arctan of x is in the open interval between minus pi half and pi. So if you multiply this by 2 times arctan is between pi and minus pi. And if you subtract minus pi, so we get 2 times arctan of x minus pi. So here you get 0, here you get minus 2 pi. So it's between minus 2 pi and 0. I can also draw the graph of this guy for you. So the one horizontal, you have two horizontal asymptotes. One is 0, one is negative 2 pi. So y is equal to 0 is one asymptote, and y is equal to minus 2 pi is another asymptote. What is the value at 0? 2 times arctan of 0 is just 0, minus pi is just minus pi. So at 0 is minus pi, and it goes like this. Let me draw with another color. I mean, actually, it doesn't touch this line, so it's an asymptote. So this is y is equal to 2 times arctan of x minus pi. And this point is minus pi. The y-intercept is minus pi, right? Good. This is just the original arctan. But if you do some transformation, here we just did some transformation on this graph. Okay, guys. So that was question 4. Question 5 is just solving equations. I leave it to you. For 6, I need to maybe give you some help or hint. So remember that arcsine, the domain of arcsine is what? What is the domain for the function arcsine? So if you have f of x is equal to arcsine x, what is the domain of f? Is between -1 and 1, right? Because sine is always between -1 and 1. So you cannot have like arcsine of 2 or arcsine of -10. It doesn't make sense. Oh, sorry, between -1 and 1. Okay, so domain of arcsine, the original arcsine is between -1 and 1. Okay, so now imagine that I want you to find the domain of this new function, arcsine of 1. So that means you have to solve this inequality. 1 minus 2x is between -1 and 1. So you just have to solve this for x. So the first thing you can do, if you subtract -1, so you get minus 2x. I mean, subtracting 1 basically, or you add a -1 to the sides of this inequality. So you get minus 2x between 0 and -2. Right? So that means 2x has to be between 2 and greater than. So that means x must be between 0 and what? One. So that's the domain. So the domain of this new function, so domain of f would be the closed interval 0 to 1. Does it make sense? Is that clear? And that's it. So you can do anything they gave you. If I tell if f of x is arcsine, I don't know. So for example, x squared minus 4. Or let me, yeah, x squared minus 4. So again, so because arcsine, you just have to look at arcsine. The domain of arcsine is -1 and 1. So that means anything inside arcsine must be between -1 and 1. So you have to solve this inequality. So that means x squared must be between 5 and what? What is the left-hand side? 3. So that means x must be between. Okay, so now here this is like a little bit tricky. So if I tell you x squared between 3 and 5, what do you know? What is the solution?
Between root 3 to root 5, but also positive or negative.
Then, so one solution, yes, is between root 5
and root 3.
Root 3. But x, for instance, can be also equal to -2. -2 is also satisfies this inequality because -2 squared is 4, and 4 is between 3 and 5. So that is also a solution. So it's between, so domain, therefore the domain of f is the closed interval -√5 to -√3 union with √3 and √5.
Wait, what did you do with a second step? Minus square root of 5. How did you get this?
Okay, that's a good question. That's a very good question. So, yeah, so let me look at this. Okay. So I can look at this. So x squared I told you that is less than 5 and bigger than 3. So that means x squared has to be less than 5, and at the same time, so this is, I say 1, and then 2 is x squared greater than 3. Okay,
Oh,
so if we look at 1, so x squared less than 5, that means x has to be between root 5 and minus root 5. And 2, so that means x is between, so here, if I want to show you on the real line, so x in this is, imagine that this is 0. This is like, imagine this is root 5, and this is minus root 5. So x must be in this interval. Okay. For 2, you have x squared greater than or equal to 3. So that means either x is greater than or equal to root 3, or x is less than minus root 3. So if I want to show you this on the real line, this is, imagine 0, and this is like root 3. This is minus root 3. So for the second inequality, x must be here, right? Now, if you take the intersection of these two solutions, so what is the common part of these two regions? Because at the same time, x must satisfy both of them, right? Right?
Yes.
So, and let me just draw this, both of them closely together, so you
So
can
it's
compare.
between square root 3 to the blue area is
I mean, let me just draw the first one here for you so you can see it. So here I just like, but by yellow. So you need to find the common part between the blue lines and the yellow region. The blue region and the yellow region. So the common part between the blue region and the yellow region would be this green region. Make sense?
Yeah.
Okay, so that means x must be
between
x is either between
that's
x is between negative root 5 and sorry, negative root 5 and negative root 3, or x is between root 5 and root 3. So that is this part. This is this part. Make sense?
Yeah.
And let me also help you to do last question, because it's maybe a little bit tricky. I want to draw a picture of a string and to compare it with a graph of cosine. So here is like, imagine this is cosine. And you have some minimum height. Imagine this is minimum height, and that is the maximum height. And also a mid. Also a mid point. So this is maximum, minimum, and this is C, the midpoint, center. And we have the T, this is the time axis, and this is the height, H. Okay, so at T equal to 0, the swing, it says that the swing is at its maximum point, right? According to this question. So at T equal to 0, the height is here, the maximum. And by the way, we know that from this information that what is the maximum? Tell me, according to this question, what is the maximum? Look at the question, please. What is the maximum? It's the question 8. Is it 5? Okay. What is the minimum? No, this question, it says 0. What is the minimum height? 1. So minimum is 1. So what is the midpoint then? C. It's between 5. Sorry.
No.
5 plus 1 over 2 is 3, right?
3.
Okay, so the midpoint is 3. Okay, so at T equal to 0, it's at its maximum. So it goes. So imagine this is the height. The thing I'm graphing, I'm plotting, is the height of the swing. It's not the swing itself. So it goes and reaches its minimum. So here, and then it goes, here the swing goes to the other side, but again at the maximum height. And then so now this is a full swing. So if you want, in terms of this, the motion of a swing, this is just a full swing. So it takes how many seconds? 2 seconds? Okay, so if this is, so the whole thing here is 2 seconds. So that means this point is t equal to 2. So that means this point must be t equal to 1.
Wow.
That means here must be t equal to 1/2. And so on. So the period, I told you, the period is the distance between two consequent maximum. So two consequent maximum or two consequent minimum is the period t, which is equal to 1. And you can say that this is also equal to 1. Okay, now, I mean, we have everything we wanted. So the period is 1. We know the point of maximum is t equal to 0. So t maximum is 0. So that means h of t. And what is the amplitude? You tell me the amplitude.
5 minus 1 divided by 2. Right?
Exactly. So don't forget the dividing by 2. It's 5 minus 1 divided by 2 is
2.
equal to
2.
So,
So
and
just
t of
put it
maximum is 0. So that means h of t is equal to a times cosine of 2 pi over t times t minus t maximum plus c. So we have everything we want. So a is equal to 2. The period is equal to 1. So you get cosine of 2 pi. And t of maximum is 0. And the midpoint, the center is 3. So if also let me just draw the picture of a swing so that I can also explain it to you what happens in this process to the actual swing. Okay. Okay, so the actual swing, so if this is the actual swing, So here is t is equal to 0. It's at the maximum height. Then when t is equal to 1/2, it comes here to the minimum height. And when t is equal to 1, it goes to the other side, but again, at the maximum height. So this is t equal to 1. And at t equal to 2, again goes back to the original position. And then goes back. Okay?